So now we'll learn about the sine and the cosine. This lesson will be very, very, very similar to the tangent lesson. So I think you'll find it easy. Just a little bit different. And then as we go through the lesson, we'll do most of the study guide together. So let's go. Apply the sine and the cosine. Okay, see I did that for you guys? Okay. Objective. Students will be able to apply the sine and the cosine ratios to determine the length and sides of a right triangle. Kind of similar. The only thing that's going to be different are the ratios that are being used. And I have up on the board the ratios as a little notes for you. So you don't have to necessarily write them down, but I'm sure they're on your study guide as well. Okay, so here's a little warm-up problem. Name the hypotenuse. Well, that's pretty easy, right? Whoa, back up. Exercises 1 through 4, and there's only 3 here. All right, just so you know, the whoops. Oh. You want to be good at identifying the parts of a triangle. Always opposite of the right angle is always the hypotenuse. So that's going to be right here. Okay. Now, wow. Now, opposite of this angle right here, remember this is like an eyeball, and the eye is looking this way, and it's looking at its opposite side. So the opposite side of angle X would be over here, opposite. And the adjacent side is the one that actually touches. It touches the angle itself. So this would be like the adjacent side. Okay, so a little review of that. When you're doing trigonometry, you have to make sure you label your sides of your triangle so you make the right ratios. Okay, that being said, let's continue. Sine and cosine. So the sine, instead of opposite over adjacent, it's actually opposite over the hypotenuse. And cosine is kind of similar to that. Whoa. In this case, it's adjacent over hypotenuse. Now, after a while, it's easy to get confused which one's which. So there is a famous mnemonic. Mnemonic is like a memory device to help you remember which one is which. And that's the phrase that I have written on the board. So, ka, toa. Okay, soka toa. Soka toa in some warm water when it's hurting. Get it? Yee. Oh. Okay, so this kind of tells you the ratios of how they go. The sine uses the opposite side and the hypotenuse. So, right? So, the sine is opposite hypotenuse. Ka is the cosine. It's referring to the cosine and the adjacent side and the hypotenuse. So, cosine, adjacent, hypotenuse. And the tangent use the opposite and the adjacent. So this little phrase will help you remember which one's which. Does that make sense? Make sure you say it right, though. Don't say sa. Sa ko. No, it's sokatoa. So you might want to think of it as sokatoa in some water or something. Sokatoa. Okay, well, that being said, let's do some practice problems. Pretty much the same stuff we were doing before. If you have this triangle, how can we do the sine of A? Or excuse me, the sine of S? Well, from this perspective, angle S is up here. So the opposite side is over here. This is where the opposite side is. And the hypotenuse, of course, is always the right triangle. Excuse me, the hypotenuse of the right triangle. So the sine of S, okay, the sine of S is equal to 63 over 65. Okay? And the sine of R now, well, let me use a different color. The sine of R, okay, the sine of R, on the other hand, it's looking from this perspective. And so if we're looking over here, this is its opposite side, so there's the opposite side. So the only difference is that this one's going to be 16 over 65. So once again, you're going to do this in your calculator and go to 4 decimal places. Stop distracting people. Okay, and we're going to go 4 decimal places. So if you divide this real quick in your calculator, 63, we get 0.969. And then the 4th decimal would be a 2. Okay. And then if you do this one, sine of r, 16 over 65, we get 0.2462. Pretty easy stuff, right? So let's go ahead and, for fun, let's do the cosine also. The cosine of s. The cosine now of s, well, it would be using this angle, and it wants to use the adjacent side. Well, see, this side here would be the opposite side. So we don't need this one. We don't need the opposite side. We need the side that's actually touching the angle. And so that one would use the adjacent side. Now once again, this is the hypotenuse again. And so the cosine of s is going to be the adjacent side over the hypotenuse. And so we're going to have 16 over 65. Okay? And so we did these two calculations already. This one's 2462. Okay? And then the cosine of r, well, in this case, we're looking at this angle over here, and the adjacent one is the one that's going to be touching it. So this is the adjacent side now. Okay? And then the hypotenuse is still the same. So in this case, we'd have 63 over 65. Okay? So you got to be careful which trig function you're using, because your calculator doesn't know, and it just does what you type in there. Okay? So in this case, we would get the same answer we got before, 63 divided by 65. Okay, so we get 0.9692. Okay, I have a little question to ask you guys now. If you're doing the sine of any angle A, remember it's equal to the opposite side over the hypotenuse. And looking at this triangle here, what can you say about the maximum value? What do you think the maximum value could be? Maximum. The maximum value of this. What can that be, the maximum value? Like the biggest number it can be, or the biggest ratio can it be? What can be the biggest ratio? Who said 1? Did you say 1? Explain. You don't know? Well, is it possible for the opposite side to be 65 and the hypotenuse to be 65? Which side is the biggest of the triangle? The hypotenuse. And it's in the denominator, right? Is it possible for the opposite side to be equal to the hypotenuse? Maybe? Think so? So let's draw any triangle, maybe like that. Even if it's like that, very skinny triangle like that, the hypotenuse is still a little bit bigger. Does that make sense? Wow, that's an awful looking triangle. Okay, so are you starting to understand what I'm getting at? Back what I was saying, the question I was asking you guys, what's the maximum that the sine could be? The sine. Remember, it's equal to the opposite side over the hypotenuse. isn't the biggest side of a triangle the hypotenuse? This is the biggest side, or the longest, right? Biggest. And it's in the denominator. Okay? This is a smaller side, right? So what's it mean when you take a smaller number and divide by a bigger number? Nobody knows? Alright, let's try this. If you have 5 here, and you pick a number that's smaller than 5, like 4, what can you say about it? It's a decimal, right? Now, if you try 3 over 5, right? Or 2 over 5, or 1 over 5, you see? Isn't this going to be less than 1? Now, this may not make sense yet, but we don't always have right angles when we're dealing with trigonometry. It turns out the sine, it does equal 1 at some point. And that we'll have to save for another class. But what I wanted you to think about is that it's always less than or equal to 1. Does that make sense? Less than or equal to 1. There are some weird cases where it can be equal to 1, but it won't be a triangle in that case. Alright, well, that was a philosophical question. I didn't know if people would get that or not. But here's the deal. Before we go much further, I want to pause the video now, and I want you to do some of your study guide. Okay, so let's move on. We got the first couple ones done. Now let's take this one step further so that we can start solving problems. Okay, so once again, you want to identify all the sides of the triangle. If we're dealing with this angle right here, according to this angle, this side over here would be the opposite side. And then this one would be the hypotenuse, okay? And of course, this side here would be the adjacent side. So let's see here. What is it that we don't know? We want to know how long the rope is. So we're going to call that one X. So on these problems, you need to figure out which ratio should you use. Based on the information, I want to use cosine because I know the adjacent side. So I know cosine of 58 degrees is equal to the adjacent side divided by the hypotenuse. So in this case, I do this in the calculator, and let's see, 58 cosine of 58 degrees. Uh, 0.5299. And of course, the adjacent side is 20, and the hypotenuse is x. So once again, to solve these, usually what you want to do is just put a 1 down here and then cross multiply, right? Cross multiply. So we would get 0.5299 x is equal to 20. And then divide by 0.5299. And of course this cancels here, and we get x is equal to, this is a 0.5299. And I get basically 37.7. They're going to say round to the nearest tenth always on these, usually. Always, usually. Okay, and so we get 37.5. Now, by the way, what if I wanted to use the sine? What what could I have done to use the sine? I want you to realize there's multiple ways to do these things. So take a look here. I want to use, what if I were going to use the sine instead? The only side that I know is 20 here, right? In order to do the sine of an angle, whatever the angle is, I have to know the opposite side, right? Over the hypotenuse, right? Well, the hypotenuse, let's take a look at this. I want you to please pay attention because it's an important idea. I don't know the hypotenuse in this problem, right? So I don't know the hypotenuse. That's what we're calling x. But if I wanted to do the sine, I can't use this angle because this side here is adjacent. But what if I knew this angle up here? Then what? You see? This angle here, this side over here is the opposite side now. So can I figure out this angle up here? Well, you guys, I know you guys just had lunch, but what would this angle up here be? Honestly, you guys are killing me. What's this angle? It's what, 32? It's complementary, right? It has to add up to be 90, right? So that angle up there has to be 32 degrees. So keep that in mind. If I want to use this angle, I could, and now I could use the sine instead of the cosine. You may have to do this from time to time. Okay? So just be aware that you could use the sine also if you find the other angle up here. So now what we would say is the sine of 32 degrees is equal to the opposite side, which is 20, over the hypotenuse. And we should get the same answer, right? So if I do this one, the sine of 32 degrees, I get 0.5299. You see? And then again, that's equal to 20 over x. And once again, what we do is put a 1 here. After that, we could cross multiply this way and cross multiply this way. And we just did this a few moments ago. And so we get our answer that we came up with before. Well, so anyhow, keep that in mind. Sometimes it's more convenient to use the sine. Sometimes it'll be more convenient to use the cosine. And since these angles are complementary, you can always find out the other angles up here. Okay, let's continue. All right, there's a couple words that come up on your homework, and I want you to know about them. The angle of elevation and the angle of depression. So the thing you need to realize is based on this picture right here, think of an elevator as going up. Like when you go to the mall in the Tri-Cities, you take the elevator. Elevators are going up. So it's an angle that's made with the horizon and goes upward. So angle of elevation. Now depression is like, think of this. This should remind you about being down. Down, it's like, oh, I feel so down today. I feel low. Depression. So think of it as going down. So that measures an angle down from the horizon. Stop playing. Okay, we're here to learn. So anyhow, anytime you see those pictures or those words in a problem, you have to draw your picture correct. Does that make sense? So let me show you another problem now. Normally the diagram would not be included, but let's make sure we have the correct picture here. It says the angle of depression. So where is this angle at? It's not here. That's what's misleading about this picture. Where should it be? It says the pilot is looking at an airport from her plane. So the pilot is here, right? And it's looking at the airport. It says it makes an angle of depression. Well, what we do, the horizon line would be out this way. You see? The angle of depression does go down. That's 29 degrees. So why is this one 29 degrees? You have a zigzag pattern, right? You guys remember what this is called? If you have a zigzag pattern, what kind of angles are? They're alternating interior angles. And what do we know about alternating interior angles? They're congruent. So this angle is congruent to this one. And so that's how you get the 29 degrees down there. Okay? So just be careful. When you're setting up your diagram, you might set it up incorrectly and then get the problem wrong. Okay, so by the way, if this is a 29-degree angle and I know this side and this side, which of the three trig functions do I want to use? Sine, cosine, or tangent? Huh? Cosine? Well, that's my angle right here. I don't know the adjacent side, do I? So I know over here, this side over here is the opposite side. And this one's the hypotenuse. So I want to use the sine, because the sine of this 29 degrees is going to be equal to the opposite side, which is 10,000 over x. Okay? And so once again, we'll use our calculator to determine what this value is. Okay? Sine of 29 degrees. I get 0.4848. And that's equal to 10,000 over x. And now once again, you can set up this ratio or this proportion, and then you can cross multiply. Okay, so I get 10,000 is equal to 0.4848 x, and then I divide this side by 0.4848, and divide this side by 0.4848, and that gives me x is equal to almost 5,000, I think. 10,000 divided by 0.4848. And that turns out to be 4,848. Now, I think this would be in terms of feet. So there's our unit, and there we have it. Whew. And so that's how much distance they have left to get to the landing spot right here. That's where they're going to land, I think. Okay, so anyhow, there's a variety of problems. I think what you should do now is work on your, I want you to work on your study guide. And I want you, oh my goodness. Who did that? All right.